Okay, 3, 2, 1. Here we go. Live with another Share Friday. Who's excited? Everyone put up their hands. Yeah. Whoop, whoop, whoop. Marvin, why don't you tell us about testing, brother? Take it away.
Yeah, cool. Very cool to be here. Very cool to continue with the spirit of Share Friday today with a bit about CI and CD, which I announced last week. So let's see what we're going to do here. So yeah, let's just dive right in. Even if it seems like it's like a presentation, I don't want this to be like a lecture. Please interrupt me anytime. It's in the spirit of sharing. Everyone chip in if you have some extra information or whatever. I'm not like the expert. I just used CICD in the past quite a lot, so maybe you guys find something that is valuable to you. Cool. So yeah, what is CICD anyway? So CI usually stands for continuous integration, and CD stands for continuous delivery or continuous deployment or continuous development, whatever you want to take from that. I'm just going to stick to delivery. There are some variances here and there, but basically the idea is to have this automated pipeline where you make use of these techniques. And in detail, I'm going to explain these, but the general goal is to have like a process where you can release software in an automated way, in a repeatable and automated way quite frequently, and still not compromise on the quality of that stuff that you're releasing. That's generally the idea why we have CI/CD today. I'm going to also talk a little bit about the history later on, but generally we have continuous integration, which is the integration of these changes into the existing code base. So for example, you have a commit or you have a merge request or pull request, and you basically in an automated way, you build it, you compile it, you maybe even test it, which is the preferred way. So for example, unit testing or integration testing. And then if all these pass, so if there's no errors in the building or compiling and all of the tests say that everything is okay, you can merge it into, for example, your main branch or whatever is that in your development process. And then you have the second part, which is the continuous delivery or deployment or development, whatever. You can also integrate manual reviews there. Some people do it, some people don't. But generally, the idea is to have automated deployment to staging and to live service later on if you want that as well. So if on the one side you have a commit and on the other side, everything is basically done after every commit. And combining these is what we call a CI/CD pipeline. So if you have an automated process that does all of this, you basically have that. So yeah, let's just look at how that works in practice. So we have the code base, and then we change something like through a commit or a pull request or whatever. And if we don't have any process, then it basically ends there because someone manually goes onto the server and pulls it and compiles it and whatever. That's probably fine for a lot of cases, but it's not very efficient and it's not really automated. And maybe we can change something about that. So what you generally did in the past, and especially companies like Mozilla and Firefox are known for this, they don't only have one commit, they bundle like several commits throughout the day or throughout the week. And at the end of that cycle, they build everything in an automated way and they test it, they stage it and deploy it. And this all is done in like a repeated fashion, for example, once a day. And this is also where the term nightly build comes from. So for Mozilla, they did it for a long time, where at the end of every week or day, everything that has been built will be compiled overnight, tested, and deployed. And this is what you call a nightly build, because every developer is at home sleeping, and then the systems can build everything. And when you get back to the office in the morning, it's all done. So that is like one of the ways how to do it. And with CI/CD, we basically push this even further because we don't want to have multiple commits in there. We want to do it after every commit. So after every single commit, you build it automatically, you test it, you maybe even review it. That's not standard, but some people do manual reviews in there as well. And then you push it to staging and to deploy it on a live system. And this is where we find our CI and CD parts as well. So this is basically what we want to do after every commit, so that in theory, you develop something, you push a new feature to your master branch or main branch, and then it's automatically on the staging server and tested, and everything's cool. So how does that work under the microscope? So maybe we are using GitLab or GitHub or whatever, and as soon as you push something or you commit something, this calls a CI runner, which is a service that's running or that's basically working in the cloud. Sometimes for GitLab, it's hosted. You can also host that yourself. And this runner is then calling or deploying, or however it's in detail, but they are calling a CI server. And on that server, you spawn a container. And in that container, you basically pull the code, you compile it, you build it, and you do whatever you want. And this container can also connect to services. So you can have like database if your application makes use of a database, or you can have a local blockchain that's running there to check everything, if everything works. All the building and testing and compiling in there. And at the end, you get a return, which is everything went fine or there was a problem. And this is what you can also see in some of the repositories where there's like a check mark after every commit. That basically means there's some form of a pipeline connected to it that tells everyone this is all fine here. And then you can go forward with that. So that's basically how it works. So yeah, why do we have CICD today? Basically, what we had before was what is even practiced today in some parts is the waterfall model, which is something like this. So you have like these stages that you can only go down, you can not go up. So if you have a problem in your design, you don't notice it very quickly and you have to reiterate through the whole process, which makes it quite inefficient, is what I think. Some people still like to do it, but this is why since the end of the 90s, we have something like extreme programming, and later on also the whole agile development movement, which focuses on having very fast cycles and still develop high quality software. So this was the whole idea of extreme programming, to have small cycles that you use and not having this long process where you have to repeat it all over again if you have a problem. So this is where CI/CD comes from, basically. So in the late 90s, the inventor of extreme programming wrote a book, I think it was 1998 or 99, where he wrote about this. And so yeah, as I said before, we had the waterfall model, but it's considered a bit slow and not agile for most people today. So we don't want that anymore. And then I think in 2001, we had the first tool that was basically the first CI tool, which is cruise control, which basically still looks the same as it does back then. So it does everything that you would think it would do. Like on the right, you can see the latest builds. You have these check marks, and you also have exclamation marks where it says, oh, something went wrong here. You need to go back and fix that. So basically, this is the first CI. I think it was last updated in 2010, so it might not be used anymore. But this is where CI and CD comes from. And today we have a whole lot of tools that we can use for that. I think the most prominent ones is probably Jenkins and Travis on that side, and also the Fox on the left is GitLab, which I use a lot, and also Jenkins. And now I think the newest and most prominent player in the space is probably GitHub Actions, which now gained a lot of attraction through just being on GitHub, because most people prefer GitHub to everything else. And now you have a very cool, very, very nice CI/CD solution on there, which is basically free if you're not like a big company that needs a lot of hours of testing and stuff. So that's perfect. So that's the current space of CI and CD. And I think I do have a little example here on how it looks like. So basically, you have in the repository where you use all of that stuff, you need to have a file that basically explains to the runner that I was showing up here. So to the runner, it says, well, what do you need to do now? You need to tell this system, what do I want to do with this whole thing? And this is what we describe in Jenkins files or in other files in YAML or whatever. So basically you tell them here, well, I have these stages, and this is, for example, the build stage where you do something. In this case, it only puts out building, but it's just an example. So in there, you could say, okay, build it and put this file here and put this file there, import this, and then everything is built. And then you can go to the next stage, testing, and you call this unit test and you interact with the system and so on. And all of this is running, in this case, in a Docker file. And this is just the Golang Docker. But what you can also do, and this is where it gets probably interesting for most projects, is you can just say, I want to have my own Docker file and then describe it in there. So you can basically describe the whole system like you want to have it for your use case, install Ganache, put this here, install the database, have everything in place. And then I can do building, testing, deploying, and whatever you want. And this is basically how you go about, talking to Jenkins and explaining what you want to be done in this system. And it's a very cool process. At the same time, going back to my earlier description, which I had, let me see, which I had here, where I had the distinction between continuous integration and the nightly builds. Sometimes, as I said, continuous integration, continuous delivery is not like this one thing that you do always like this. I personally see it more as a set of tools that you can just take whatever you want from. For example, in the last company that I worked for, I was working on a backend that was written in Go. So I had a system exactly like this, which is perfect because building it and testing it takes like a couple of minutes, and then you push everything. And after 3 or 4 minutes, you have a result, whether you did something bad or whether everything's cool. But we were also developing software and operating system for embedded devices where if you build that thing from scratch with all the crypto libraries, it would take a couple of hours. And maybe in that case, you don't want to have it after every commit. And in that case, we also went with nightly builds because it's not fun waiting for 5 to 6 hours after every commit. So you just might as well do it at night. So it's not like this one thing that you use and everything else is bad. It's just a toolbox that you can use for whatever you want. And that's very important to keep in mind. So
yeah. I guess how I see CI is really about making the iteration loop as small and tight as possible, and getting feedback to developers. So obviously everyone benefits when there's a fast iteration loop, but it's actually mostly for developers. So the product team obviously get a better product and they're happy, but the people who really notice how nice it is working with a smooth pipeline are the developers, because I make a change. Let's say there's a pre-commit hook. So that's when I try and commit my code with Git, it immediately tells me there's a flag, fix this. Or even earlier, it's all about getting feedback really fast. And basically, once there's a pull request and all of the sort of boxes have been ticked green, then the person reviewing the code has a lot of confidence that the code is pretty good. Obviously, they still need to review it and look at it and see if there's bugs. But if there's a really good pipeline before the pull request can be merged, it means the job of the reviewer is much easier and they can focus on the important things, which are, code architecture, structure, more high level things, and they don't have to like check if it compiles or something mundane. Yeah. So that's sort of my view of it, especially the CI aspect.
Absolutely. I mean, the only excuse that I had for not using CICD before I did it, or especially CI, was I was just too lazy to do it, basically, because if you used it once, you don't want to go back to doing everything manually. It makes your life a lot easier. Can only recommend that.
Oh, and that was a killer Share Friday. There's some great slides. Enjoyed that.
Thank you.
Did anyone else see a resemblance to AWS of that library from 2010?
Yeah, they must have used the same UI library.
I just found it funny that you're referring back to so long ago. It still looks like.
Oh, yeah.
a bit like AWS now.
No one.
Another sort of tip that I learned at my previous company. We were doing CI before, and a really experienced DevOps engineer joined the team, and one of the first things he did was to standardize all of the commands for CI. So we were at the time using Circle CI, and everything was like, if you looked at our Circle CI config.yaml, there was a lot of like hard-coded stuff that was very, very specific to Circle CI. And the first thing he did was he said, no, like that's not how you do CI. It should just use like a make file, or that's what we used. You can use anything, and it should have a thing that says build, run tests, like very high level. And your config file should only call that. It shouldn't call, update this and then start the database, and like it shouldn't be a command. It shouldn't be the orchestrator of your tests, because that really locks you in. You want to be able to switch between CI, CD type of tools very easily, and making all your commands very high level in a make file that executes the things means you can, let's say Circle CI increase their prices and you think it's rubbish or whatever, and you want to move to the newest thing. It should be 5 minutes. You just copy the make commands, like the execution, and you can move to Jenkins, you can move to GitHub Actions, you can move to GitLab, So yeah, just a good tip. Don't put too much in the config file.
Marvin, one last question on my side. I can't say I'm the Mark Zuckerberg of testing, so maybe if I wanted to get going with running my own CI/CD pipeline and I have a repo in GitHub, what would you recommend as like the first couple little steps for, say, me to start?
I would say I'm pretty impressed with GitHub Actions, to be honest, because you can basically, it's just the only difference to other CI solutions might be that you describe it in a different way. So it's, the syntax, but generally, you can have very, very fast and very quick, how do you say, like, good results if you just do the first, even if you just start off with, I put it into a Docker and I build it and I have the binary there. Even if you don't do anything with it, you just notice that, oh, you can also, I don't know, test if it runs and test one first command. So playing around with it really helps. And for me, it was also when I started doing that stuff, you just have to do the first step and then you immediately see, oh, that's so cool. It's when I do this commit, it automatically happens here and I get this green check mark or whatever. So yeah, probably Jenkins is probably the most prominent open source solution. So if you don't want to pay anything for it, probably go with GitHub Actions or Jenkins, or one of the most widespread ones, and then just play with it, have fun.
Cool. I'll make sure to get Jason to set that up this weekend.
We've got some CI pipelines already.
Yeah, I know.
But yeah, no, we've definitely neglected a lot of that stuff. It's more difficult doing that if you're trying to do everything as a tiny team. It actually does take a lot of work. And although I mean you have a lot of benefit, even if you're a lone developer having all of that set up, a lot of that integration work really shines when you've got bigger teams, because then you can have 10 developers committing code to the same repo all the time, every day. And because the tests run, that the integration of those pieces of code has to be correct. You don't have to worry about strange side errors, etc.
Yeah, totally.
Another thing which I think is quite neat with these sort of pipelines is you can actually create artifacts during the pipeline. So
like logs and stuff.
Sure, logs. But like, for example, let's say you have a UI that you want to run some regression tests on. There's off-the-shelf tools, and obviously you can make custom tools. We did this at my previous company. Basically, it spins up a Puppeteer instance. So Puppeteer, for those who don't know, is a browser automation tool. So you can run a website and you can say, click on this button, open that tab. You can do all of that stuff with code. So that's part of the
writing
testing
a scraper.
suite. Yeah, you can write a scraper with it.
Yeah, take screenshots of your site for stuff like that.
So with this, you can run that in your CI and take screenshots and then compare the new screenshots with the old screenshots. And there's tools that like highlight things in red if it changes. So, if you have some UI developers building something, it's sometimes really difficult to know what their change looks like. And the artifacts from your pipeline can tell you immediately, and it makes it so much quicker to review. And just another thought.
In case you're your CSS engineer, done some funny font changes and stuff, you can see those things out. Sweet. Guys, I think that was pretty great. Anything else?
Awesome. Shawnee, you've been very quiet.
Yeah, I mean, I don't have much to add. I don't know about any of that stuff. I mean, we do all of that at AWS, but it's all internal tools. I mean, it looks exactly like that, right? It's like how you outlined it. It's the same shit. Yeah.
Can I suggest something, Sean?
Go for
Next week, can you for Share Friday, either share with us, there's two things I want to learn more. Either the AI system you made for your blackjack game, like 6 or 7 years ago, or that.
Like I remember that.
You remember that? Yeah.
No, I don't remember.
Oh, your complex number viewer. Sean,
No, but you should do
complex
that.
number viewer.
Dude,
That
I
would be
haven't
cool.
looked at the code in years.
Oh,
I don't even
okay,
have
so
it with me. Wait, no, I
now
lied.
you
I
have
do
a
have
week's
it with me.
notice, bro. So it's fine. You got a week's notice. Or the I think you did an agent-based modeling simulation for people getting on and off planes, didn't you?
Oh, yeah. That's the most
Yeah, I
recent
remember you
one.
telling me about that one.
I could do that. I could probably remember that code easier than the other code.
Okay, sweet. Well, I reckon you should do one of those. Maybe the one of people getting on and off the plane. That was
Yeah,
cool.
that's cool because I don't think anybody knows that language.
Yeah, I don't. What is
Yeah.
it? Is it in? No, is that a Nets logo?
Yes, exactly.
Oh, okay. Yeah, I played around with it once or twice, but I don't really
Okay.
know. But yeah, let's do that, dude. Are you happy to do that next week?
Yeah, that's fine because I'm not working next week, so I'll have time to set something
Oh,
up.
sick. Yeah, perfect.
Yeah.
Perfect.
I mean, I don't think I'm gonna have a slideshow as professional as Marvin's, but I'll just do a screen share.
Perfect.
Yeah,
Looking forward to that.
Sweet.
Perfect.
cool.
Cool,
All right, cool guys.
Cheers, guys.
Ciao.
Cool. Ciao.
Bye-bye.